Right, let's find the equation of the parabola that is sketched right here before us. So two ways of doing it. One is to look at the x-intercepts, which we'll start with. And then the other way is to have a think about how the vertex is moved. So we're just going to start by looking at where the x-intercepts are. So I'll zoom in on this a little bit, and we can see that the x-intercepts are here and there, and they occur at, looks like, -1 and -3. So we'll just rub those out and write that in. That's -1, that's -3. So now that I've got those, it could be very straightforward, and that makes that x plus 1 and x plus 3. Because what we're doing is, it's in this particular form here, it's y is equal to sort of x minus a, x minus b, where a and b are the x-intercepts, and they are -3 and -1, and we've put both of those in. So that gives us that equation there. What we have to check is to see, is this your standard parabola, or has its shape been changed by a particular scale factor? And we can check that. Because if it is a stock standard parabola, then it's going to behave in this way. It's going to go 1 to the right, 1 up, check, 2 to the right, and 4 up. So you can see there that that's the equation for us. So that's very simple. We don't need to do anything else. That's the equation. We've got it right there. It's that one there. Let's expand that out, because it'll just show a couple of other things. Notice we didn't bother checking the vertex. We didn't bother checking where the y-intercept is. But if we expand this bracket out, not in green because it's the wrong color for expanding. If we expand this out, I get x squared plus 4x plus 3. And you can see here that 3 is there as the y-intercept. So that all fits as well. And we have this line through here, which is our line of symmetry. The vertex occurs at this point right here. And that's worth noting as well. And that vertex occurs at -2, -1. And we can write that down. All right, so that's the equation. So y is equal to x plus 1, x plus 3. And if we expand that out, we get x squared plus 4x plus 3. They're both the same line, both the same equation. Now let's look at doing it in a different way. And we'll rub all this rubbish out and start again. Clean slate. So we're looking at this, and we're going to use this idea of how far has that vertex moved. So, well, it's gone down 1, so that's -1, and it's gone to the left 2, so that's -2. We've already determined this is a standard parabola. There's been no scale factor change. So if we do this and we use this one over here, where I get x minus b squared plus c, where b is the horizontal translation and c is the vertical translation. So you can see there the horizontal translation is 2 to the left. So we can fill that in on what we've got. And so that becomes x minus -2, and x minus -2 is x plus 2 squared, and then plus c. Well, we've gone down 1, and so that plus c becomes -1. And that's the equation for it as well. And as I've mentioned, there's no need to worry about a scale factor, which we would have snuck in there, but we're not looking at that. Let's expand this out and see whether we get the same equation, because we should. If this is the same graph, then we should have the same equation regardless of the form that we find it in. So expanding that out, x plus 2 squared is x squared plus 4x plus 4 minus 1. And I get y is equal to x squared plus 4x, and 4 minus 1 is 3. And that's exactly the same equation that we got before. So this one obviously the same, and this one's the same, and the one up the top there are the same. So we're looking really at 3 different forms of the same equation. and one graph.